Yeah, we're looking for the particular YP for this second order differential equation, non-homogeneous. Okay, and we're still using the method of undetermined coefficients. Look at what we have. We have this minus y equal to 5x squared. Yeah, this is similar to the question we just solved in the last video. Okay, but there's a little difference to that. Before you can get the YP, you must get the YH, the homogeneous equation, I mean the homogeneous solution. And for us to get the homogeneous solution, the given problem must be equal to what? Must be equal to 0. Then we can get the auxiliary equation of this, which will be equal to r squared minus 1 equal to 0. And this will be equal to what? R minus 1 is equal to 2 squared, r plus 1 equal to 0. And that will be equal to r1 is equal to 1, and then r2 is equal to minus 1. Okay? In the previous questions, both r1 and r2 are the same. But in this case now, they are not the same. So your YH now is equal to C1 EX plus C2 E minus X. Okay? So let's now get the particular solution, YP. The YP is easy. Look at what we have in root 3 for the undetermined coefficient. We said if f of x is equal to c xm e rx. Okay, so our m here is 2, which is a quadratic, so that will be equal to what? Ax squared plus bx plus c, and then put that exponential function by the side. Okay, so the question I have to ask is that the question to ask now is the solution, I mean the auxiliary roots, are they equal to the r you have here? Okay, if one of them is equal to the r you have here, which is 1 here, only one of them is equal. In that case now, it what? To this. Don't forget, we said your yp for this expression will be equal to what? We check the notes. That will be equal to, yeah, this will be quadratic in nature. It will go on to maybe power, it will be quadratic in nature, maybe power m and so on and so plus. It's going like that. So what we just need to know is just that if one of your roots equal to this, then your x is what? X is 1. So that's what you want to establish. And that's that. Okay, so that will be your yp. So the yp, you can do the expansion for this, and that will be ax3 plus bx squared and then plus what? Cx equal to what? Ex. In the previous questions, previous video, these two were equal. So then we can get the fourth differential, yp equal to what? 3ax squared, 3ax squared plus 2bx, then plus c, ex, then plus second through, then plus ax power 3 plus bx squared, then plus cx, then differentiate this one now. Okay, so that's the first differential. Can we get the second differential? The second differential will be equal to y p equal to, and the first one, that will be 6ax plus 2b. Okay, the differential of c is a constant is 0. Yes, then plus. Now keep this one constant and differentiate this. 3ax squared plus 2bx plus c. Differentiate your exponential now. Okay. Then the second part plus that will be 3ax squared. This one, differentiate that, 3ax squared plus 2bx. Okay, plus c. Okay, ex, then plus. Keep this one constant and differentiate this. ax3 Yeah, plus what? Plus bx squared plus cx ex. Okay, so that's what we have the second differential. We have the first differential, we have the second differential. What is my first differential? Okay, that's my first differential. So what can we do now? We need to plug in back to that place. But before plugging in, we can see something here. These two is the same. These two is here, the one here. So that will be 6. Substitute back here. That will be 6. 6 ax plus 2b ex, then plus 2 of this, the same. So 3 ax squared plus 2bx plus c ex plus c, ex, then plus the last one, x 3 plus bx squared plus cx equal to ex. So I've done this. Then minus y. Minus my y is what? My y is that's ax3 minus ax3 plus bx squared plus cx, the bracket what? Ex. Okay, equal to what? Equal to 5s squared ex. Okay, so this one and this one cancel out. Those two cancel out. So I have the remaining 2. So let's see what we can do to that remaining part. So we're going to equate the coefficients according to this one. Let's extract that. We only have these 2 now remaining. We only have that 2 remaining. So here, 2 times 3a, that's what? That's 6 a x squared ex. If you open that, yeah, that's ex. So can you equate that to this? If you equate that, 5s squared ex. Okay, so that one cancel out. 6a equal to 5. A is what? 5/6. A is 5/6. Okay, then we still have another value. We have b, we have c. So what we do now is to equate. Let's equate this one. Let's equate this. The coefficient of x, 6a x ex is here. Another one again is also here too. Plus 2 times 4b. That's 4b x ex. Okay, equal to what? Equal to 0 x ex. We don't have it on that side. So we can equate the coefficients. If you do that, you equate the coefficients, that will be 6a. 6a plus 4b equal to 0. And the a is already 5/6 plus 4b equal to 0. So that will be equal to 5 equal to plus 4b equal to 0. So b will be equal to minus 5/4. B is minus 5/4. Then we can get the c. The c, let's see where we have the c is the constant. The c, okay, we have here. To get the c, we can have 2b ex. This one, 2b ex, and followed by what? Plus 2c ex equals what? Equal to 0 ex. Okay, so equate the coefficients. So we have 2b plus 2c equal to 0. Okay, so then we have b already. 2 times minus 5/4 plus 2c equal to 0. And that will be 2 here 1, 2 here 2, that's minus 5/2 equal to 2c. So So C will be equal to what? Minus 5. I think minus 5 over 4. Yeah, minus 5 over 4. That's C. There is a little rotation here. Here. This is a minus 5 over 2 of 2C equal to 0. Okay. Then 2C equal to 5 over 2. Then C is equal to what? 5 over 4. So that's C. Then the particular solution they are asking us to get will now become YP over 6, 5 over 6 x3 plus B. B is minus, so minus 5 over 4 x3, then plus C 5 over 4 x. So that's that. Then you can close it. You can close it. EX. Okay, so that's solution. That's the YP they asked us to get for that.